Welcome back to another class, and we're going to continue with logarithms, and this part we're going to look at common logarithm. We had an introduction to logarithm, and now we're going to look at how can we get logarithm of numbers using a mathematical table. So first thing that we need to understand is that when you look at our mathematical table, we have numbers that are in between 1 and 10, meaning that in any case we want to look for a logarithm of a number, it has to be in that form. Our number x there should be greater than or equal to 1 and less than 10. That's what we are provided with by the table when you want to go about that. And generally, when you look at our table, these numbers are going to be, the bases are 10. So the values that are going to get there, if it is a logarithm of maybe 2, that is when we have the base being 10, the power we can raise to 10 to get us 2. So let's have some examples. We see how we can be able to do that. Example 1, we want to get the logarithm of 2.943. So this number is going to be direct from our table. So we are going to first read the values of 2.94, the first three numbers there. Then on additional part, we are going to add the value that corresponds to 3. So 2.94 is 0.4683. So this is same as this is going to be 10 power. Now the 0.4683. That is the logarithm of 2.94. Then we add the value that corresponds to 3 on addition part, which is going to be 4. And this 4 we add to the farthest end there, to the right part, that 4 there. So we are going to be having 10 power 0.4687. 3 plus 4 is 7. Now this is the logarithm of 2.493, that is the 0.4687. In other words, when we have 10 power, this number here is going to give us 2.493. Basically, we just write it as 0.4683. That is the logarithm of 2.493 to the base of 10, or just using the table. Let's have another question. Logarithm of 695. 695. We want to get the logarithm of that number. And the first thing that we see here, 695, it is more than our age here of a table that is beyond 10, is greater than 10. Now, we have to make sure that that number you can use the table. And how do we go about that? Of course, we write that number into standard form. So 695, we are going to write it in standard form. So we are going to be having 1, 2, that is 6.95 times 10 power 2. So that is 695 into the standard form. Then we look from our table the logarithm of 6.95. So we go to our table and then we look at 6.95. And this is going to be, of course, that is the power, the logarithm, the base is 10. So it is 0 point, everything is 0 point in that table. This case is 0.8420. 8420. Then we are multiplied by 10 power 2. This 10 power 2. So basically the 6.15 is the same as 10 power 0.8420. Now, remember we had the laws of indices where we are multiplying, they have the same basis, 10, 10, we add the power. So this one is going to be 10 power 0.8420, we add 2, so it's going to be 2.8420. So the log of 6.695 there is 2.8420. That's how you can be able to use the table to get the logarithm of a number that is greater than 10. And then you can have another case here for a number like this, part C. We have 472,000. 472,000. We want to get the logarithm of this number, 472,000. So this, we are going to try this one into a standard form because it is beyond our range, which we need to have a number that is greater than 1 and less than 10 for us to use table. So in this case, we write it to standard form, 1, 2, 3, 4, 5. So we get 4.72 times 10 power 5. Then we did the logarithm of 4.72 from our table. 4.72 going to be 10 power what? 4.72 is 0.6739. That is the logarithm of 4.72, the same as 10 power 0.6739. Then you multiply here by 10 power 5. And using the rules of indices, bases are the same. We usually add the powers. So you add this 0.6739 to 5, you get this same as 10 power 5.6739. Generally, the logarithm of 472,000 is going to be now 5.6739. We now look for logarithm of numbers whose are less than 1. We have looked for the numbers that are greater than 1. Then we look at for those numbers that are less than 1. So number D, we are going to have a logarithm of 0.314. 0.314. We want to get the logarithm of this number. It is less than 1. Our range here is using the table greater than 1 or less than 10. Now 0.314 is less than 1. So how do we go about it? In the same case here, we are going to have this number written into standard form. So 0.314 is going to have 3.14 times 10 power negative 1. So here we read the values of log of 3.14, which is same as 10 power 0.2. 314, you get 0.4969. 0.4969, then times 10 power negative 1. So here when we are going to add these two, we are going to have 10 power. Now you don't write minus 1, 0.4969 plus minus 1. This minus 1 we write it as bar 1. So it's going to be bar 1.4969. Why is it bar 1? Because it is only that this part that is negative, not the whole part is negative. That's why we write it as bar 1. So the logarithm of 0.314 is bar 1.4969. Is the logarithm of the 0.14. Let's have another question, the last one for this part, and number E. We get a logarithm of 0.0098. Logarithm of 0.00098. So the same case, this 0.00098 is less than 1. So we write it into standard form. 9.8 power how many? 1, 2, 3, 4 times 10 power negative 4. So we get the logarithm of 9.8. So that is going to be 9.8 is 0.9912. 0.9912, of course, times 10 power negative 4. And in the same case here, we have this is the same. They have the same basis, so we have the powers. And because this is minus 4, we don't write minus 4. We write it as bar 4. So it is good to read bar 4 point, then 9912. So this is going to be the logarithm of 0.00098 is the same as bar 4.9912. That is how we go about that. And maybe something that we need to understand here, when we have a case like this, the logarithm of a number, like let me give a positive number, 2.3, maybe 214, that is the logarithm of number. This part here, the negative part is called Mantissa. It's called Mantissa. And then this whole part here is called characteristics. And the same case goes to the logarithm which is having a bar number here, like this bar 4.9912. So this part here is the Mantissa, and then this minus 4 here, the whole number part is now the characteristics. So that is what you need to understand when we talk about the logarithm. Otherwise, thank you very much for your time.